Let's talk about negative exponents and how we can deal with them. The first idea I want to get across is that when you see a particular variable raised to a negative power, that doesn't mean the number is negative. It's not negative at all. What it means is that we're looking at a reciprocal. If I have 2 to the negative 1 power, this is equivalent to 1 half. So if I had, for example, the number 50 and I multiplied it by 2 to the negative 1 power, this is the same as me taking 50 and multiplying it by 1 half, and I would get the value 25. You can verify this on your scientific calculator, and it's good practice to look at and think about that. So anytime I see a negative exponent, I'm thinking, oh, this is a reciprocal. And it doesn't matter if the negative exponent is in the numerator or in the denominator. So for example, if I have 1 over x to the negative 1, that's the same as x to the positive 1. One of the ways that I like to illustrate how you can easily and efficiently get rid of negative exponents is simply by multiplying by the number 1. So let's consider the expression 12x to the third divided by 6x to the negative second power. Part of this problem involves the fraction 12 over 6. Well, the fraction 12 over 6 is indeed 2 times 6 over 6, and I see that I have a giant 1. So I'm left with a 2 in my numerator. But in terms of this negative exponent, in order for me to efficiently remove it, I simply choose to multiply this problem by x squared in the denominator and x squared in the numerator. The reason why I've selected x squared is because when I multiply x to the negative second times x to the second, I end up with x to the 0 power, which equals the number 1. So effectively, I've changed this problem into 12x cubed x squared over just the number 6 times 1 times 1. That's 6 times 1. This is the 1. And of course, I don't need to keep writing that I'm multiplying by 1 because 1 is the identity element. Anytime I multiply by 1, I don't change a thing. That's why I'm allowed to multiply this expression by x squared over x squared. So if I finish this, because 12 over 6 is the number 2, I end up with 2 and then x to the 5th power. So again, multiplying by the number 1 allows me to eliminate negative exponents. Let's consider another example. Let's say that I have 15x to the negative 4th power divided by 3x to the second. Again, the exponents have nothing to do with the 15 over 3. This is just a fraction, and I can reduce that. 15 is 3 times 5 over the number 3. Clearly, the 1 is 3 over 3, and I'm left with just a 5 in the numerator. And to eliminate my negative exponent, I'm going to multiply this time by x to the positive 4th over x to the 4th. I'm looking at this negative exponent, and I selected x to the 4th because I know if I multiply x to the negative 4th times x to the positive 4th, I get x to the 0 power, which equals 1. So in my numerator, I'm left with 15 times the 1. My denominator has 3x squared x to the 4th. If I simplify this, we're left with just a factor of 5 in the numerator, and we are left with 6 factors of x in the denominator. Finally, let's consider an example that has some multiple things going on. Here I have 2 times 3x squared to the negative second over 3x cubed. The problem that I'm having is that I need to know exactly what this is. I need to deal with the fact that I have something being raised to the negative second power. And the way that I deal with that is I'm going to multiply this precisely by 3x squared to the positive second power over 3x squared to the positive second power. Already this is easier for me to look at because I know that 3x squared to the negative second power times 3x squared to the positive second power equals the number 1. So my numerator is the number 1, is 2 times that 1, right? There was a 2 here. So 2 times 1. And in my denominator, I still have the 3x cubed, and I'm multiplying that by 3x squared squared. Well, for me to square the 3x squared, I need to have two factors of two collections of those factors. So it's a 3x squared times another 3x squared. 3 times 3 is the number 9. X squared times x squared is x to the 4th power. So this 3x squared, that entire quantity squared, can be rewritten as 9x to the 4th power. In my denominator now, I have the number 27, 3 times 9, and I have 7 factors of x, x to the 7th power, and in my numerator I have the number 2. I know that there are not common factors with 2 and 27 because 27 is just built with 3 times 3 times 3. So this would be my final simplified answer.